Hi, in this video we are solving another sample midterm 2 from the fall 2017, and again this is from chapter 3 and 4. The first question is asking you to differentiate the following functions, and we are given a function f of x equal e to the power of something with the variable x. Now we know that when we take the derivative function of e to the x power, we should get e to the x, the same function as e to the x. Now, the given function is no longer e to the x. Therefore, we have to use the chain rule to the exponent here. So that's why I let z to be x squared plus 3 over 2. And this is the chain rule by letting z equal to the term that's mass of the basic function. And now, we should get this is e to the z power, and when we take f prime, we should get the same thing, e to the z. We get e to the z. We take the prime, it should be e to the z, and we multiply by z prime because this is the chain rule. That's why the f prime here is e to the z, and z is x squared plus 3 over 2. Remember, at the end, we must plug back everything in terms of x and multiply by z prime, and z prime is this function. Take the prime. So this term stays the same as this one, and this is the z prime function. And when we take the prime of finding the derivative function of this term here, we can use the power rule. Now, imagine that the 2 here is just the 1/2 the constant, so it's just stay as the 2 at the bottom. And then all you have to do is take the power rule of the x squared. So bring down x squared 2, subtract 1 from that. Number 3 is a constant. When you take the derivative, you should get 0. That's why we got 2x over 2 here. And we can simplify this further. The 2 should cancel out, so you should end up with just a single x, which is right here, multiplied by e to the x squared plus 3 over 2. And that is the answer for part A. Now moving on to part B. Part B has a function of g of x equal 5 to the power of 2x. And remember that anytime that we have the function as a to the x power, and then when we take the prime of that, you should end up with a to the x, the same thing, and then we multiply by the ln of a. So ln of a is the base, so ln of a is multiplied by the same original function, which is the derivative of a to the x power. So a is any constant, any base, and x is the variable on the exponents. So in this case, we don't have the power of x, but we have something with 2x. So again, this is the thing that's matched of the basic function. That's why I let z to be 2x, z to be 2x. And now the function g should be 5 to the z, and when we take the g prime, you should end up with what? 5 to the z according to this one, 5 to the z, and then multiply by the ln of the base 5. And don't forget multiply by z prime because we're using the chain rule. Therefore here I have ln of 5, which is right here, multiply 5 to the z, multiply 5 to the z, and z is 2 times x, and multiply by z prime, and z 2x, so 2x prime. And all we have to do now is just finding the derivative of 2x, which is 2, because this is the power of 1. So 2x just become 2, and we just keep the ln of 5, and then 5 to the 2x as before. And that is the final answer for part B. Now for C, we are given two functions. Two terms. x multiplied by ln of 2 plus x squared. Now, all we have to do now is remember that when given the product of two functions f and h, we let the first function to be f and the second function to be g. In this case, f is x and g should be this function. So the product rule is saying that we take f prime times g plus g prime multiplied by f. That means I take the first function f prime or x prime times the second function g, which is ln of 2 plus x squared, plus g prime, which is ln of 2 plus x squared, take the whole thing prime, multiplied by f, which is x only. And in this case, the derivative of x is just 1, so I don't have to write 1 here. And carry out ln of 2 plus x squared. And plus here, again, we have to take the derivative of ln 2 to z squared prime. And now, go back to the basic formula. We know that given ln of x, when we take the prime of that, you should end up with 1 over x. This is the basic formula. But now, the argument inside here is no longer the x, but now it's 2 plus z squared. And that's why we let z to be that thing that messes up the basic function. 2 plus x squared, and that is the z. Right here, this is z. And now that's why when we take the, when we rewrite this term in here, which is ln of z prime, when we take the derivative of that, we should get 1 over z and multiply by z prime due to the chain rule. So 1 over z, and z is 2 plus x squared right here, and multiply by the chain rule z prime, or 2 plus x squared, and then z prime. So this is the answer for taking the derivative of ln 2 plus x squared, and we keep the x from the outside, right? Multiplication. And z prime, which is 2 plus x squared, take the prime, take the derivative function of this one. Using the chain rule, the constant 2 becomes 0. 2x, bring to the power, subtract 1 from that, that's become 2x. So this whole thing here becomes 2x. So 2x here, multiply 2x over here, give me 2x squared, and then divide by 2 plus x squared. And we keep the first term as before. So this is the final answer for C. There's only 3 parts here. Okay, the next question. This one, let's read the question first. It's saying that a BC manufacturer estimates the amount that T months, so T months from now, it will sell X thousands of its model X units per month, where X equals this expression here. The profits from the manufacturing and selling X thousands of units is estimated by the equation, and this is the millions of dollars. Now find the rate at which the profits will be increasing 5 months from now. So we are finding, the key word here is we are finding the rate of the profits. Remember, the rate of change is the derivative function. So all we have to do is we are finding the P prime. P is the profits. The rate of that, which is P prime. So all we have to do is P prime, and then plug in T to be 5 months, and then estimate or find the value. Now, we were given a function P equal 0.001x squared plus 0.1x minus 0.25. However, the x variable here is the function of the time t. That's why when I rewrite here, I make sure to include x of t, because x is a function of t. And now, everywhere I see the x, I have to go back to the definition for the x, which is 0.05 t squared plus 2t plus 5. So x squared, which is that whole thing here, square, plus 0.1 multiplied with x of t, and x is again this function here right here, and then minus 0.25. Now you have to this is the function p of t, again still p of t. All we have to do is we are writing x in terms of t because x is given at this expression. Now we need to find p prime, so all we have to do now is try to find the derivative function from this whole thing right here. Now when we take the derivative function, remember this is the constant, so it stays at 0.001. However, this thing here is the thing that's messed up the basic function for the x square, because if I just got x squared, I know how to find the derivative function, but now it's no longer, the base no longer x, but it's the whole expression here. That's why we have to use the chain rule, and all I have to do is I let this whole thing to be z. So we have z squared. When we take the z squared, when we take the derivative function of that, we just bring down 2, so that becomes 2z, and we multiply by z prime due to the chain rule. So all I have to do now is 2 times z, so 2 times z in this whole function inside here, and multiply by z prime, and z prime is this inside function here. Take the derivative function of that. So I bring down 2 using the power rule. 2 times 0.05, which is 0.1 t, and then 2t become 2. The constant phi becomes 0. That's why we have z prime, which is z prime with this guy right here. And doing the same thing to the next one, I keep the constant 0.1 from the outside, and then this guy is easy. We can take the prime by just using the normal power rule. Bring down 2, which becomes 0.1 t. Subtract 1 from the exponent. That's why we got t here. And then 2t become 2. Number 5 is a constant. The derivative function. The derivative rule of the constant is 0. And then again, this is also a constant, so that becomes 0. So this is the whole function for p prime of t. And all we have to do now is plug in t to be 5 months to here, and anywhere you see t now become 5. So doing all the plug in here and using the calculator, you should end up with 0.33125. This is the rate of change of the profit after 5 months. However, this one, the units for the profits is in million of dollar. Let's go back here. This is million of dollar for profits. So we got to millions means the power 10 to the 6th. That's why if I move 1, 2, 3, 4, 5, 6, so that's become 300,031 to $50 per month. The rate of change is this much of dollar for the profits per month. Okay, let's move on to the next question. Now, this question, number 3. Currently, 1,800 people ride the A train each day, and they pay $4 for a ticket. Now, the number of the people Q, this is the quantity of the people, the number of the people Q willing to ride the train at the price P is Q equal this expression. The railroads would like to increase the revenue, so is the demand elastic or inelastic, as P equal 4, as the price of $4 right here. and should the price be raised or lower to increase the revenue. Now we know that the demand functions is f of p equal q. This is the demand function, and we can find when the price is $4. That means when 4 is p, $4, we have 1,800 people that is riding the chain each day. So f of 4 should be equal to 1800. Now, how do I find the elasticity of demands? Remember, the elasticity of demands is equal to we can just find the absolute value. So the absolute value of minus p times f prime of q over f of p. This is the formula for the elasticity of demand. So all we have to do is we have to find the formula for the elasticity of demand and then plug in 4, the prior 4, and see what's the value of that. We know that p stays as p, right? And f of p is given here. F of p is the q, which is the demand function, which is right here. So f of p is 600. Okay, we have, this is the demand function f of p equal q, and let me try to rewrite here. So we know that q equal 600, so multiply 5 minus right equal p, and f of p equal q is given as q, which is also equal to this guy here, 600 multiplied by 5 minus radical of p. And remember, the square roots mean the power of 1/2. Now we want to find f prime of p first. So f prime of p, that means finding the derivative function of this guy right here, and the constant 600 stay as 600 outside. Now using the power rule to the inside function, when we take the derivative function of 5, which is a constant, that becomes 0. And then this is the power of 1/2 due to the square root, so bring down a 1/2, bring down a 1/2, then p, subtract 1 from 1/2, which is minus 1/2. Okay, minus 1/2 right here. That's why f prime, when we multiply 600 to minus 1/2, because this is just 0, so 600 multiplied by minus 1/2, that's give me minus 300 right here. And then p to the minus 1/2, I can bring it down to the denominator and then put the minus 1/2 to become a positive, or it just get back to the square root of p at the bottom. So this is the function for f prime of p. And we go back to this formula. Okay, so the absolute value side will take care of the minus here. Now p stays here. F prime of p, which is minus 300, or we can just keep the minus here. So minus and minus will cancel again, the same thing. And 300 over the square root of p, so 300 over the square root of p, that is f prime. And on the top we still have p, therefore p is right here. So this p is this p here. And 300 over square root of p is right here. And f of p at the bottom it's just right here, which is Q, or 600 times 5 minus radical of P. That's why we got this expression at the bottom here. And then doing the simplification, divide on the top by 300 and 600 by the top and the bottom by 300, we got 2 at the bottom. And this is the P to the first power, this is to the 1/2, so they have the same base B, we dividing them, that means we subtract the exponents, or 1 minus 1/2, which give me 1/2 on the top, or it's just radical of P. And at the bottom is still again 5 minus radical of P. And that is the expression for the elasticity of demand. And all we do now is we are testing the value when the price is $4, because we want to find what happened at this price P equal 4. So when P equal 4, I plug 4 to here and here. I got 1/3 for the elasticity of demand, and 1/3 is less than 1. That means this is inelastic. Less than 1 is inelastic. Bigger than 1 is elastic. Now, as at this price of P equal 4, the demand is inelastic, and the price should be raised to increase the revenues. The demand is inelastic. That tells you if you increase the price, people still buying your products. That's why you should increase the price. Here, you should increase the price because people will keep going to the chain even if the price is raised. That's why you should get more revenues. And that is the conclusion from this question. The next question, finding the second derivative of 2 over x squared plus 5 square root of 5 x. Now, to find the second derivative, all we have to do is find the first one first, and then do another, taking another derivative to get to the second one. Now, the original function, I can use the power rule to find the derivative functions by just rewrite the bottom x squared, move it to the top, putting the negative on the exponent. The radical, the square root become the power of 1/2. Now we can use the power rule. Bring down -2 to 2, that gives me -4. And -2, subtract 1 from the exponent, that's become -3. And then bring down 1/2 to 5, so which is 5 with 2. Subtract 1 from 1/2, which is -1/2. From here, we take another derivative function using the same power rule. So bring down -3, go to -4, that's become 12. Subtract 1 from that is -4. And then -1/2, bring it down here, multiply to 5/2, which plus times minus give me minus. 5 times 1 is 5, 2 times 2 is 4 right here. Subtract 1 from -1/2, that becomes -3/2. And that is the second derivative of this function g. Okay, next question. Let's g of x to be this function. Find the x coordinate of all the critical points of this function. Remember, the critical points are the points that make the f prime function to be 0. So all we have to do, in this case, g prime function to be 0. In this case, all we have to do is finding g prime using the power rule. So I bring down g 3 to 2 thirds, and 3 when I bring it down here is cancelled with the bottom 3, so that becomes 2 only. Subtract 1 from 3, that becomes 2. 2 times 2 is 4, subtract 1 from 2 is 1. -6x becomes -6, the constant becomes 0. And we can solve this one to be 0 by factoring methods. I can see that 2, 4, -6, they all have a common factor of 2. So I pull out a 2. The first terms I have x squared left. When I took out 2, then 4x becomes 2x, and -6 divided by 2 give me -3. And I can further factor out this trinomial x squared plus 2x minus 3, which becomes x minus 1 and x plus 3. The reason that this is the case because -1 times 3 give me -3. -1 plus 3 give me +2. And that's why these two are the factors of this trinomial. And setting this equal to 0 to find a critical point means that one of the factor here must be 0. That's why I set x minus 1 to be 0 or x plus 3 to be 0. Now solving for x is easy. Adding 1 on both sides, I got x to be 1. Minus 3 on both sides, I got x to be minus 3. So 1 and minus 3 are the critical points of the function g of x. And then the next question, they ask us, use the first derivative test and the second derivative test to determine the function, to determine which of the critical points are the local max and which one is the local min, and confirm your answers by the two tests. Now this is a good review for using both ways, the first derivative and the second derivative. We can confirm this test easily here. Now, after you got the critical points minus 3 and 1, I plus minus 3 and 1 on a number line system. Now that's divides into 1 area, 2 area, and then 3 area. I pick one point to the left of minus 3 and I plug back into fg prime, and I got that to be 0. I mean bigger than 0, so it's increasing, and I pick one value between minus 3 and 1 and putting that value into g prime function, and that's give me negative. So it's decreasing, and then one value to the right of that is got increasing for g prime. So we can see increasing, decreasing. So this is local max as minus 3, and then going down and going up again. This is local min when x is equal 1. Now let's try the second derivative test. In order to use the second derivative test, we have to know g double prime. We got g prime here. Sorry, go back here. Where is it? Okay, g prime is right here. Right here. So we can apply the power rule to find g double prime. So bring down 2, that's become 4x, and 4x become 4. The constant minus 6 becomes 0. And this is the g double prime. And we got the two critical points. So all we do now is we plug in 1 and minus 3 to g double prime. When g double prime as x equal 1, I got a positive value, which is bigger than 0. And bigger than 0 for the second derivative is positive. Positive means we have concave up and the happy face, right? And that's give me the local mean right here. And when I have the minus 3 as the g double prime is negative, less than 0, that is the sad face, or we should get the local max here. And yes, the two locations, they are the same thing with the first test. So 1 give me local min, minus 3 give me local max. They are consistent. So yes, they are the same thing. Okay, the next question. The following figure is a graph of the derivative function f prime. So this function is f prime. Indicate on the graph the value of x, the x values that are critical points, and label the maximum, and label them as the local max, local min, or neither. Now we know that the critical points are the point that make f prime to be 0. This is the condition that we set earlier to find the critical points. Now this is the function f prime. This is f prime. So all we have to do is we look for the location of x that make the f prime to be 0. It is equal to 0 right here and here because the y value is 0, and that's why these two locations are the critical point. Now on the left side of the critical point, positive for f prime, so it's positive. And then on the right side of this point is negative, so it's positive and negative. Therefore we should get local max at this point. And then from here, on the left side is negative, on the right side is positive. It's about the x-axis, so negative to positive. That's why it's local min at this critical point. So local max is here, local min is here. We can tell from the graph of f prime. Okay, let's get to the next question. Now the next question. Jump Burgers finds that it costs $50 to produce a certain burger, and that's the fixed cost at $300 per day. The price function is p of x equal 150 minus 5x, where p is the price in dollars, as which exactly x burgers will be sold. Find the numbers of burgers Jump should produce, and the price is subject to maximizing the profits. So the key word here is to max the profits, or finding the local max. Now, again, the key point here is the profits function. We need to get the profits function. We know that the cost function c of x can be found by the information here. It's $50 for each burger that we produce. So 50 times x is the variable cost, and the fixed cost is $300 per day. So we are adding $300 no matter what the value of x we have here. We still have to pay $300 for the fixed cost. So 50x plus 300 is c of x, the cost function. The revenue function is the quantity times the price, right? Quantity, the number of the burgers sold multiplied by the price. The quantities in this case is the x burgers. So x is the quantity multiplied by the price, which is p of x function, which is right here. And so x multiplied by 150 minus 5x. If we do the distribution of that, x multiplied by 150 minus 5x, we should get x multiplied by 150 or 150x, and x multiplied by minus 5x or minus 5x squared, which is right here. Right. Now the profits is the revenues of x minus c of x. So we take this function minus this one, right, and do the simplification. We should end up with this one. And notice that x should be bigger than 0 because x is the number of the burgers, exactly the number of the burgers will be sold. So it should be bigger than 0. Now to maximize the profits, or to find a local max or local min, we need to find a critical point. So to find a critical point, we find p prime, take the derivative function of this profits function, and I can do that by using the power rules. Bring down 2, so 5 minus 5 times 2 is minus 10x. Subtract 1 from the exponent, plus 100x, that's now become 100, and the constant minus 300 becomes 0. And letting this one to be 0, because we are setting the p prime to be 0, and we can solve for x to be 10 from this linear equation. So x equal 10 is the critical point. And to decide if this is the max profits or the min, or the local max or local min, we can use the second derivative test in this case. So because I got p prime of x equal minus 10x plus 10. So when I took the second derivative function, minus 10x become minus 10, 100 become 0. So notice here, the second derivative is always less than 0 because it's minus 10. It's minus 10 is always less than 0. So there is an absolute max value of p as x equals 10. The second derivative is always less than 0 no matter what the value of x. Less than 0 is negative. Negative for the second derivative is concave down, so it should give me the local max. Or you should get a max value as x equals 10 in this case, because number 10 is the critical point, and this function does not depend on the variable x. Therefore, it's negative, it's always give you the max. So you should produce 10 burgers, and that will give you the maximum profit. And the price for the maximum profits, the profits should be 10 plug into the profits function right here. For anywhere you see X, plug in 10, and you got $100 for the max profits. Okay, the next questions. The total profits from the sale of charcoal grills is given a P of X. This is the profit. Find the average profits. Now the average profits is the same idea as the average cost, which is the cost divided by the quantity. The same thing here. The average profits is the profits divided by the quantity. So the quantity here is 40 reels, so it's 40 for the quantity, and P of 40 as the level of 40. So anywhere of X, I plug in 40, and that's give me the average profits of 11.20. To find the marginal, the average profits as a level 40. So this is the average profits. The profit function divided by the quantity, or X. And if I did the simplification here, I took P of X, which is this function, and then divide by X. So each term on the top divided by X. The first term, X squared divided by X, only X left here. 20X divided by X give me 20. Minus 320 divided by X, I can bring the X up to the numerator, putting the minus sign. And from here, in order to find the marginal average profits, this is only the average profits. So to find the marginal, I take the derivative function of this whole thing here, and using the power rule again. Minus 0.02x becomes minus 0.02. 20 is a constant, becomes 0. Bring down minus 1 to here, become plus, and subtract 1 from that, become minus 2, and 320. So that is the marginal average profits, and they want the level of 40. So we plug in 40 for X that we see here, and plug in that to the calculator, should give me minus 0.18. So the average profits per reel, remember this is per quantity, so per reel is increasing by approximately 18 cents. This is in dollar, so 0.18 should be 18 cents per additional reels when 40 reels are produced. So that means if we are at a level of 40, and if we produce another reel, we should get another the average profits should increase by 18 cents, because this is positive, so the rate should be increasing for another extra additional reel. Then the average profit should be increasing at the rate of 18 cents. The next question. Find the global max and min of this function on this interval, and then find where the function is concave up and where the function is concave down. Now, to find global max and min, again I have to get the critical points. So f prime from the power rule, bring down 3, subtract 1 from 3, that's 2. 2 times 3 is minus 6, subtract 1 from 2, that becomes 1, minus 9x become minus 9, plus 5, the constant is 0. Now I can factor out the common factor 3. The first term has x squared, minus 6 divided by 3, and minus 2, minus 9 divided by 3 give me minus 3. And then this is the perfect, the leading one's coefficient of the trinomial. I can factor that into x plus 1 and x minus 3. And finding the critical points, I set that expression to be 0. That means one of the term here should be 0, or the factor here should be 0, and minus 1 on both sides. I got minus 1. Add 3 on both sides, I got plus 3. And minus 1 and 3 are a critical point. in order to check for global max and min, we must also consider the two endpoints -2 and 6, and to check for the global max or min, we use the original function to test for the value of the original function at the two endpoint and at the two critical points. So all we do now is we are doing the testing. We know that's -2 and 6, they are the two endpoints. -1 and 3, they are the critical points. So we plug all the four values here to the original function f, and we compare the value. The lowest value -22, this is the global max, and the highest value is the global min. This is not global and global min and max here. This should be the typo. And so the value is 3 for x. The y value is the f of 3 is -22, and 6 is x, and the y value 59 is the y value. So this is the coordinates of the two the global min and global max. So this should be global min, and this is the global max. Right. Okay. The next one is find the concavity of that. To find the concavity, we have to take the second derivative function, and finding f prime from f double prime from f prime. All we have to do is, again, this is f prime. F prime is 3x squared minus 6x minus 9. So taking the power rule again, that should give me 6x minus x equals 0, and we need to get the critical point for the f double prime. So we're setting this one to be 0 and move the 6 on both sides, and then divide by 6 on both sides. X to be 1 is the critical point, so x equal 1 is the critical point. Now it's divides the number lines into two areas, the left side and the right side. I pick one value on the left side 1. I test for f double prime. I get something less than 0 or negative, right? Remember the sad face, and there's something some number on the right side 1. I got that to be positive, which is the happy face, concave up. So yes, we do see a changing of the concavity from the left side of 1 to the right side of 1, and that is the inflection point. And the concavity on the left side of 1 is concave now. Let's go all the way from -infinity up to 1, but not including 1. And then the concavity for the right side is concave up. Right side of 1 is concave up. So you go from 1 up to all the way to positive infinity. That should be the interval for concave up. So 1 is the inflection point. The left side of 1 from -infinity to 1 is concave down. 1 to positive infinity is concave up. Okay, so that is the end of the sample exam. And thanks for watching.